Alright, so today's lesson objectives. Students will represent relations and graph linear functions. So again, hopefully this is all review, stuff you remember from before, but in case you forgot a little bit. A relation can be a mapping or pairing of input values. A mapping or pairing of input values with output values. Okay, a mapping or pairing of input values with output values. So your domain, you remember what domain is and what range is. You remember that from algebra 1? Or like, you're thinking of statistical stuff like you could get out. Okay, so alright, so the domain is your input, okay? And so when we're doing XY graphs, it's your X values. And then your range is the output for Y values. So what we get for Y depends on what we put in for X, right? So Y depends on X. That means this is our dependent variable. And that means X is our independent variable. Okay? So it doesn't matter what X is, I can plug it in, but Y depends on X. So it's dependent. So there are 4 different ways that you can represent relations. We can represent them as ordered pairs. We can represent them in a table. We can represent them in a graph or in a mapping diagram. Alright, so for example, we're going to consider the relation that is given by the ordered pairs -2, -3, -1, 1, 1, 3, and 2, -2. So first I'm going to identify the domain and the range. So it really is as simple as just listing your X values. Oh, I always want to get yummy. Like romaine salad, I guess, or something. Okay, domain. So it's going to be -2, -1, 1, and 2. And then my range, which is my Y values. And so -3, 1, 3, -2. And if you want to write them in order, you can. It's up to you, but it doesn't matter. So if I'm going to represent them as a graph, these are actually just discrete points. Okay? It's not a line or anything like that. You just graph the points if they tell you to represent it as a graph. So -2, -3, -1, +1, 1, 3, and 2, -2. That's my relation as a graph. Then I can also do it as a mapping diagram. So this is my input, my output. So I'm putting in -2, -1, 1, and 2. I'm getting out -3, -2, 1, 3. Alright, so when I put in -2, what did I get? What goes with it? The -3, right? When I put it in -1, what do I get? No, what goes with the -1? A 1. What goes with the 1? When I put in a 1, I got a 3. When I put in the 2, I got a -2. Okay? So that would be representing it as a mapping. Alright, so you guys are going to tell me the domain and range for this one. Alright? I want to know the domain and the range on your whiteboard. Okay, so for your domain, you guys got -4, -2, 0, 1. Do I need to write the -2 again? No. And then for the range, we got 3, 1. Do I have to write the 3 again? No. -2 and -4. Okay, everybody agrees? Alright, so go ahead and draw a mapping of the relations for me. Okay, so how many ordered pairs do we have? 5. So you should end up with how many lines? 5 lines. So when I put in the -4, I got out a 3. When I put in the -2, I got a 1. When I put in 0, I got 3. When I put in 1, I got -2. And when I put in -2, I also got -4. So I put mine like counting up. If you put them in a different order, yours might look slightly different, but that's in a nutshell. Okay? So if it asks for a mapping, that's what it wants. If it asks for a graph, then you graph it and so on. Okay? Okay, so a function is a special relation where each input has exactly one output. Okay, each input has exactly one output. Alright, so we're going to tell whether the relation is a function, and then we're going to explain it. So if I look at letter A, I look at each input, and it's only going to one output. -3 only goes to 2, -1 only goes to 3, 2 only goes to -4, and 4 only goes to -4. So each input has one output. So notice it's okay to have repeats in the range. It's okay that 2 different input values gave me the same thing. If I just look at the input side, I don't have 2 arrows going from my one input. But if I look at B, what happened over here? The input 1 has 2 separate outputs. So is that a function? No.
So it can't really be repeating inputs for it to be a function.
Right, if the inputs repeat and get something different, then it's not a function. Now, if I was just listing ordered pairs, -2, 4, 1, 3, 5, 7, and I put in a 1 again and I still get a 3, that's still a function because I got the same exact thing the second time I put it in. So just be careful, be aware of that. But if I had gotten 1, 7, say, then that would not be a function because I got 2 different outputs for both. Okay? So I know because the input 1 has 2 outputs. So yeah, it's okay to repeat on the range, but you can't repeat essentially. Alright, so on your whiteboard, this is just a yes or no question. Tell me whether the relation is a function. Yes or no? Okay, so looks like you guys all agree yes, right? And why? Why is it yes? Yes?
Because all the inputs have an output.
All the inputs what?
They have an output.
Have different outputs?
Uh,
No? So
they all have an output, like,
they only have one of them, you mean?
yeah.
Okay,
There's
all the inputs
there's no repeating input.
have only one output. Okay, but what if I extended my table right here and I put -1, -4?
No, that's not. No.
Is it still a function?
No.
Yes, it is still a function.
How?
Because I got the same thing. It's the same output. So that's why I was saying you can't just look for repeats and memorize it that way. You have to think about, and if I wanted to be tricky, I would give you a problem like that to see if you were paying attention.
Nah, I failed that.
Just one problem.
Okay. All right. So do you understand why that's still?
Nah, but we can go on.
Well, because when I put in a -1 the first time, I got a -4. When I put in a -1 the second time, I still got a -4. I got the same output. So that's the only output that I'm getting for -1. If I put -1 again and I still get a -4, I'm going to put -1 again and I still get a -4.
What if you get -3?
As soon as I throw something else in there, it's no longer.
But it says exactly one output. That's exactly two outputs.
No, -4 is the same as -4. It's only one
But
output.
it's different negative four.
It's the same value. Okay? All right. We'll agree on that hopefully now. Okay. All right. So vertical line test. Hopefully this rings a bell also. Just reviewing. So if it's a function, I can have a vertical line. I'm going to draw myself a. Ooh, not very vertical, is it? Basically, I can take a vertical line and go across the graph, and it only ever touches the graph one time as I move the vertical line across. Okay? But if it's not a function, when I go across, it's touching in multiple places. Okay? So therefore, it's not a function because it crosses more than once. Okay? So a vertical line crosses the graph one time. Here it crosses the graph greater than one time. So it's not a function. Okay. So graphing. You can, when we're talking about equations in two variables, you can make a table to graph. You can always make a table. So you construct the table of values. You plot points that you found, and you connect with a line or a curve, depending on how the lines line up. So as you're coming up with your points, you want to look and see if there's a pattern. Is it making a line? Is it making a curve? You want to put in enough values that you can tell what the graph is doing. So for example, if I want to graph y equals -2x minus 1, I can just make myself an xy table and just pick some numbers. It's usually a good idea to do both positive and negative numbers. So if I do -2, I get 4 minus 1 or 3. If I put in a negative 1, 2 minus 1 is 1. If I put in a 0, negative 1. If I put in 1, get negative 3. And when I put in a 2, I get negative 5. So I'm just inputting them into that equation. Okay? And then I plot the points. So when x is negative 2, y is 3. When x is negative 1, 1, 0, negative 1, 1, negative 3, and 0, negative 1. So I can see that it's making a line. So I just connect them with a line. How would you know that this is linear? If I hadn't graphed it yet, how would you know that this is linear? There's no what? No, I'm not talking about the table right now. I'm just talking about the equation. Like just looking at that equation. What'd you say in the back? There's no x squared or x cubed, right? So it's linear when the highest power is 1. Okay? So if it's got an x squared or an x cubed or x to the 5th, it's no longer linear. That's when you're going to be using a curve. Okay? And are you guys good on this one? Okay. So for this one, so linear functions, again, the graph is a line. And the highest power is 1. You can do it in xy notation, so that's your good old y equals mx plus b. Or you can use function notation, f of x equals mx plus b. So both of those are valid ways of representing a linear function. So if I look at my first linear function there, negative x squared, f of x equals negative x squared minus 2x plus 7. Thumbs up or thumbs down? You guys think that's linear? Just show me thumbs up or thumbs down. You can take a second from writing to show me thumbs up or thumbs down. I know you guys don't all have broken thumbs. Is A linear? Okay, the answer is no, because look, it's not linear because of the x squared. That one's going to be what shape? You guys remember? A parabola, yeah. That one's going to be an upside down parabola. All right, what about g of x? Thumbs up or thumbs down? Is that one linear? 4 people have thumbs. Just 2 more thumbs. Yes, that one is. So that one is just going to be a line. Okay. And that's pretty much what I have for you. We're getting close to time, so I'm just getting out of the whiteboard.